Hello, good morning, and welcome to today's webinar, which offers insights into how you can bring MATLAB, Simulink, and Arduino to the engineering classroom. Thank you for taking time out and being here with us today. Before we jump in, just a few housekeeping items. We'll be running a live question and answer session towards the end of the webinar. Please feel free to use the chat feature on your participant panel and pop any questions you may have in there, and we will address them when the time comes. Also, if you miss any part of the content presented today, not to worry, we'll be sending around the on-demand recording when it's available. My name is Pamela Cyphers. I have worked in product development and design for the EdTech industry for more than a decade. I also currently fill a marketing leadership role with Pittsco Education. With me today are two colleagues, one from Arduino Education and one from MathWorks, that I'm very pleased to introduce. The first is Roxana Escobedo. Rox has a background in design, communication, and education. She has experience in researching creative teaching and learning, as well as in designing learning environments for students and children with different learning abilities. Currently, Roxana works at Arduino as an education partner trainer. Also with us today is Chad Alley. Chad is a customer success engineer for MathWorks that partners with university faculty in their teaching and research endeavors. The goal of Chad's role is to help customers discover and explore how they can use MATLAB in their work to ultimately create a more interactive learning experience and streamline workflows. Before joining MathWorks, Chad worked with Boeing commercial airplanes in Seattle as a propulsion engineer, focusing on complex fuel systems for commercial and military aircraft. This type of work exclusively used MATLAB Simulink to design, analyze, test, and certify the final product. I would like to personally thank Rox and Chad for being with us today, and will officially turn the presentation over to them.
Thank you, Pam. And welcome all. Thanks again for joining to this new Arduino Engineering Kit webinar. And I also would like to thank Pamela and the Pittsco team for organizing this webinar and make it possible. So if you're ready, let's get started. So today we're going to have the Engineering Kit REV 2 webinar number 2, which is we're going to talk about only software. So as Pam said, I'm Roxana. I'm from the Arduino Education team, and today our special guest is Chad Ali from MathWorks. So, but first, what if you couldn't make it to the first webinar? I want to show you a recap of the things we discussed, so you can also like have fresh your minds. I'm going to show you a short video before we start. So here it goes.
And help them develop mechatronics engineering skills. The kit provides extensive learning outcomes, giving students a strong understanding of robotic engineering concepts through exciting and explorative projects that create a hands-on learning environment. Students are able to associate what they learn through real-world applications. They're encouraged to think critically and improve their depth of knowledge by being introduced to theoretical concepts through experimentation. You can use this versatile kit as the core module of a new engineering mechatronics class, or freely adapt the content to your own ideas and experiments while working with implementing MATLAB and Simulink. The Arduino Engineering Kit REV 2 enables educators to tailor the kit to the students' needs and their own curriculum. For example, it can be used as part of laboratories and final projects. The kit provides everything you need for a full in-depth learning experience, including online learning material with lessons and step-by-step instructions for students to work in small groups or for facilitating remote learning. At the same time, students can also buy their own kits and use it to experiment at home for extended learning.
All right.
Challenge students.
Okay, so that was a short recap of what we saw on the last webinar, where we talked about what was the engineering kit, the benefits, access to the platform, and all the like an overview. So just like remember that you have anything you need in one box. You have access to the online platform, access to all the materials, hardware and software when you buy the kit. So on this webinar number 2, we're going to focus on the software. So we're going to talk more in detail about what is MATLAB and Simulink. Remember that this kit was developed and designed in collaboration with them, with MATLAB. So our special guest is going to talk us more in detail what is MATLAB Simulink, where he's going to show us all the benefits and how MATLAB and Simulink work together with Arduino in this kit. He will show you all some practical examples, some models, and then we will have the Q&A session. So for this, before we introduce Chad, we want to show you a very short video about the importance of using MATLAB and Simulink and the collaboration with Arduino for develop this kit.
In order to prepare students for real-life environments, we partnered with MathWorks to develop this kit. You will learn how to use MATLAB and Simulink to program and control robots.
MATLAB and Simulink are built specifically with engineers in mind. Whether you're designing a controller for your motorcycle or programming a path for your rover, or even working on an image processing algorithm for your drawing robot, MATLAB and Simulink are going to make the complex math and engineering computations easier and more intuitive. This is really why top engineering schools around the world use MATLAB and Simulink in both curriculum and research. It's also a sought-after skill for graduates looking to work in areas like robotics, medical devices, and autonomous vehicles, just to name a few.
All right. So now, after this short recap, now please welcome our special guest, Chad Ali. As Pam mentioned, he works at MathWorks. He's an Edu Customer Success Engineer, and he's going to tell us a little bit more about MATLAB, Simulink, and how they work together with Arduino. So I'm going to give Chad the controls now. So Chad, are you ready?
Yes, I am. Thank you, Rox. I appreciate that.
Thank you for joining today.
Let's, absolutely. Happy to be here.
Thank you so much.
All right.
So remember, if you have any questions, you can write them in the chat and then we can answer at the end. So
Yes, please do that as I go along in the event I don't see them along the way. So again, thank you everyone for attending. Again, just a quick recap about myself. My role focuses on working with professors and researchers, deans and chairs all across the country, all across the world for that matter. I work on a larger team that supports academia at large. And our goal is to make sure we can show you the value of how MATLAB and Simulink can help support your teaching efforts or even your research efforts at many different universities. And speaking of universities, as of today, we have about 1,700 universities around the world that are actually utilizing what we call our campus-wide license. And what that is a license that supports the entire university in itself, that supports all the different products we have, over 100 different products for MATLAB, along with our self-modulated training suite to get students ramped up or even faculty ramped up on different material, and even the auto-grading tool for assessments that can be integrated into learning management systems for schools, amongst other things. And then with that, there are even many students and faculty, or roughly over 140,000, that are actually using MATLAB and Simulink to program hardware. This is a very important skill to have because many of the jobs that they're going to be looking for in businesses actually utilize these products to do similar things. So having new hires have these skills will be even more beneficial to these businesses. On top of that, many of these same MathWorks products are used within research areas. So ultimately, it just shows that there is a wide array of usage across the board. And speaking of these different industries, here's a snapshot of just a short list of just a few of the industries that MathWorks touches in terms of where our products are used. Now, one of the things to notice here is how in depth this screen is, along with many other industries that we do touch. One of the big things that they look for here is how our products can help support business initiatives and solving their problems and projects. But of course, we must believe that it doesn't start here. It starts actually right here in the primary and secondary schools, K through 12. And through this program with MathWorks, we actually help make sure that high schools and elementary schools and things like that can actually acquire MATLAB in order to introduce students at an early age to coding and expose them to the STEM field. We even offer courseware and examples that professors can actually use or teachers actually use to get their students started. Even some hands-on learn to code modules that help students at any age or level get familiar with what it means to program. And even at that, at the earliest ages, right, we want to get students touching some kind of hardware and get familiar with it, which can help change the trajectory of their futures. And speaking of that hardware, that kind of leads us into what we plan on talking about today, which is how MATLAB works with Arduino. And as you may have already guessed, we'll be focusing on the balancing motorcycle itself to discuss how it actually uses MATLAB and Simulink to operate. But before we get there, we do need to start with the basics, such as what is MATLAB and what is Simulink. So with that kind of brings us to our agenda, where we're going to jump into MATLAB, give a perspective about how MATLAB works, user story of a company that actually, or companies that actually use MATLAB, and then actually a physical demo to see how the product works in action. Then we're going to follow that same trend with Simulink. And then finally, we'll give you some resources to help you get started, and we'll have our Q&A afterwards. So let's jump right into it. So what is MATLAB? Well, MATLAB overall is a high-level programming language that allows you to develop code, to develop algorithms, to visualize your problem, to solve any kind of problem that you may have that's computational based, and furthermore, help you support any data analysis, right? I think as engineers, as scientists, what we do is we focus on working with data. And we need a way to collate that data into one common place to either process that data to visualize it or learn something more about it. And so that's kind of the environment in which MATLAB works. And you can see a screenshot of it here, and we'll jump into the physical product shortly so you can actually see it in action. Now, one thing I want to talk about is that MathWorks products focus on workflows rather than acting as a singular tool. So when we look at our products like MATLAB and Simulink, we focus on workflows and solutions. One of those specific ones, at least from the MATLAB perspective, is the data analysis workflow, something that I just kind of touched on. Where first you start off with accessing your data, right? Everyone has some kind of data that they need to use or acquire from somewhere, right? Whether it be from, let's say, Excel files or text files, something like that, right? Where you have data stored. Or maybe it's coming from software. Maybe some other application is generating some information that you have to go use. Or furthermore, maybe you're using some hardware such as Arduino to receive data off of and perform some kind of operations on it. Right? So the whole first step in this workflow is access. How do we bring data in? The next one is exploring and discovering, right? Once we have that data, we want to learn more about it. What does it mean? What is it? How does it help us get our job done, right? So there comes the idea for visualization, analyzing and modeling and understanding how that data works. And then even finally creating algorithms to help better express the behavior of that data. And then once you've gone into the explore and discover phase a little bit more, now you take it to the sharing, right? Nothing works without being able to share your information with others, or even present it in a way in which other people can learn. So in that same format, right, you can focus on, once you've developed your algorithm and things like that, you can actually create your own report and documentation, or even deploy it as code onto a completely different device. So let's take the motorcycle, for example, right? That's a piece of hardware. We might get some sensor data out of that as our what we're accessing, right? We're accessing that data that comes off of a sensor on the motorcycle. Then we want to understand that, right? We're trying to help the purpose of that motorcycle is to help make sure it balances. So based on the output data of that sensor, you might want to look at developing an algorithm to help figure out how to make sure that that specific parameter stays within its bounds in order for the motorcycle to balance. And then once we've come up with that, you know, we can create a report on it to share with our colleagues or with our students of what we've done. But even better, we can actually deploy that code back onto the Arduino unit so that we can actually get it to balance as we expect it to. So that in itself is a workflow. That's how we look at MATLAB, is more focused on the workflow perspective. And then finally, one of the big areas in which MATLAB excels is that we help to automate these things. So especially in this explore and discover phase, right? Typically, you end up developing an algorithm, and you got to go develop it again or develop a new one. With the power to automate, this makes it easy to do just with the click of a button, to where you can set up your system and not have to do it over and over again. So this is going to end up saving time on the back end as you go through your modeling and development. So let's get into a user story quickly about what BMW, who's actually used this exact workflow, right? They had an issue with oversteer in their cars, making it unsafe for cars to be able to be driven at higher speeds or on turns and things like that. And they want to make sure that it's safe for people to operate under all conditions, right? It's a safety thing, which is paramount in engineering. And so what they did is they gathered data from their test car. They then took that and created an algorithm, deep learning one, in order to better understand and detect when oversteer is starting to happen. And what they did is they automated that algorithm to the point where it could always sense and understand what's happening, so that it could correct the system when it starts to get into that area. And so once they did that, then they generated their own code in real time on the vehicle to test it out again and continuously develop and make sure that the system was working as intended. And that's a typical workflow, right? And what they ended up achieving was they were able to identify oversteer with greater than 98% accuracy, which is a very impressive feat to accomplish. So with that, I want to show you a quick demo just to walk through a little bit of what the MATLAB environment looks like, and give a quick perspective on that. So here, and I should be able to see that. Yep. So here in MATLAB, for those of you that may not be familiar, this is the typical interface that you would see. Here you have your current folder, which gives you some information about where your information is coming from, what you're using. Here is your command window, where you can put in different programs, different if you want to call it variables, right, or parameters. Code in general is where the command window is where you execute much of your code by freehand. And then when you create variables and things like that, you end up with things that show up in what's called your workspace. This is where your information is actually captured when you enter it in the command window, such as, let's say, x = 3. That's going to show up as X in my workspace. Now, this is just the bare bones front end of MATLAB, but there's so much more to it, right? Here in the tool strip, there are many interactive ways to work with MATLAB. For instance, we have live scripts, right? And so I'll show you an example of that, where with this live script, we focus on a data analysis workflow. This one is specifically for fuel economy, right? So the idea here is you want to focus on understanding how data changes with what the historical fuel economy data looks like for different cars and different vehicles. And so in this live script, what it is, it's a way in which you can put all your code into and execute it there and save it as a file to reuse, right? So right then and there, you have an ability to technically automate the process you're trying to achieve. And with live scripts, you can add a formatted text, titles, pictures, your output of your code and the code itself as a way to learn and understand how a lot of these analyses are being done. These could be used. Think of it as an interactive notebook that you can use for either lab reports, or you can even use as a professor for lecturing to your students on a specific topic. And so if I go through some of this, I have a table of contents I can go, and you can start to see some of the topics here that touch on that data analysis topic, such as importing data, right? So here I'm talking about importing data. I want to bring in data. I want to access my data, right? And it's in the form of an Excel sheet. So I'm just bringing in data into MATLAB to utilize. And then what I want to do is I want to visualize it, which I get to see here, what exactly is happening based on some parameters of that fuel economy, such as the miles per gallon and the horsepower of the car. And I get a nice scatter plot that gives me information about what that data looks like. But in data analysis, I want to better understand correlations, right? I want to understand what this information actually means. And so when I start to break it down into different aspects, such as, you know, car and city and truck, et cetera, I get a much different perspective of what miles per gallon horsepower looks like for a car on a city or a car on a highway or a truck, et cetera, right? But you couldn't glean that from this original set of data. And that's one of the purposes of data analysis, is to help you visualize and understand what your data really means. And once you have that kind of perspective, then you can go into creating, let's say, a curve fitting, right, for this data to better understand and find a way to represent what that information actually means to you or means to someone else that's trying to use it. And so by doing that, right, you create a trend that's going to help you define this information with a simple equation, right? Something that you can pass on to someone else in a report that they can use based on that data to make their claims and so on and so forth. And so once you have all that information, right, now you've taken some time to go and understand your system. Now you can, at the click of a button, you can create a generated report to go and actually share with others. So here, when you save it, you can export to a PDF. And what that PDF shows is exactly what I came up with. This is the PDF of that exact interactive notebook, where I can still have my table of contents. I can show you the code that I used, and I can have my output information all in one, and I can easily share this PDF with others so they can see the work that I've done. Now, there are many ways to look at this. We can look at this as a notebook that we can automate certain data analysis algorithms to help us do our work. Or we can take it from another perspective of where we want to make it more interactive, let's say. So MATLAB apps is actually a way to make things far more interactive, where you don't have to worry about programming necessarily. So let's say I want to use this is a way for students to get familiar with the data and information without having to actually look at code or write code, right? Because maybe that's might not be the focus of the course. I can use this app, which is the exact same thing as that live script, to actually develop or actually process and give me that same information that I'm looking for, right? And so this allows students to explore, discover, and get familiar and understand how this works. And then they can go back and actually generate code from an app so they can actually see what's happening under the hood, right? So there's different workflows and ways in which you can achieve this, but these are all ways in which can get you started and understanding more about how a system works. And so here in the apps tab up top gives you some perspective about where you can actually design your own apps, which is what I just showed you now, your own designed app. Also, there's a set of apps that are in here as well that can help with your workflow and things that you're trying to do, such as we just used the curve fitting one, which is the one I showed for the fuel economy. But there's also the optimization. So let's say, as Dan was mentioning, there's a mobile rover robot for Arduino that follows a specific path. We can use this optimization app to help us figure out what the most optimized path is for that robot, depending on what it's trying to accomplish. So there's different ways in which we can approach and integrate some of these works into how we do things. Coming back to the motorcycle now, we also have a live script for this motorcycle. Again, the example focuses on Simulink. However, we can apply some of these same methods to the motorcycle, right? So even in here, we have an example of what our system might look like for the self-balancing motorcycle. And so if we take the same data analysis workflow, we can apply that here in this live script if we wanted to, right? I can say that I'm trying to access sensor data from our motorcycle, right? To find out what that angle is to better understand how to make it balance. I take that data in, I look at that I start to explore and discover more about what that data means. I have a controller algorithm that I create to help keep that parameter within the bounds that I need it to be in order to make it work successfully in balance. And then I can go and deploy that code back to my Arduino once I'm satisfied with understanding the behavior of what I just developed. And that in itself is your data analysis workflow. All right. So if I jump back into our presentation real quick, I want to get into discussing a little bit about Simulink and Simscape now. So what is Simulink, right? So Simulink takes it a step further, a layer of abstraction. It's a graphical block diagram environment that allows you to model and simulate, create and test as many times as you want to create the system that you're trying to develop and ultimately automatically generate code. And so it's a block diagram system, right? So imagine if you don't want your students to have to code or have to learn to code, they can express similar things with block diagrams instead. And if we take it one step further to Simscape, Simscape is a part of the Simulink package, the Simulink family. But it takes it one step further where it focuses on physical modeling of systems, such as things that we're all familiar with in the real world from electrical or mechanical or thermal or other areas that we've been exposed to. So what's the difference between all three? Why would you use them under certain conditions, right? Well, MATLAB is going to focus predominantly on the programming aspect, right? And the data analysis workflow. With Simulink and Simscape, I can focus on the model-based design workflow, which we'll get into in a moment. But as a quick aside, with MATLAB, let's say I'm looking at a resistor. This is an electrical component, a typical electrical component for students to use when they're understanding how circuits work. And you can see that physical component right here. Now in MATLAB, I would actually go into MATLAB if I want to define a parameter for a resistor, such as R equals 10. That would be my resistance value for what this resistor actually means. or what it represents. But if I go back to Simulink, I can represent that in a block diagram, right? I don't have to write that as code, right? So we're taking it layers of abstraction further. Finally, if I go to Simscape, now I'm focusing on an actual real representation of the resistor itself. So that's the difference, right? In MATLAB, I'm programming the actual equations that represent a physical component. Whereas in Simulink, I'm taking blocks to develop, I'm using blocks to represent that same equation without having to write any code. In Simscape, I'm using effectively one block to represent all of those things, the equations and everything else that it represents. So these are just different layers of abstraction, how you choose to teach or how you choose to model. It's really up to how the problem you're trying to solve. And so with that, let's get into model-based design workflow. So let's take this as, let's use an example that we might all be familiar with, such as drones. So in drone technology, right, when you start with the idea of model-based design is you want to break down a problem to better understand it, and then eventually build it back up slowly and integrate it, right? This is a commonly known industry workflow, right? And Dan was mentioning it in the video earlier, right? Is you want to be able to have your students or others or anyone for that matter be able to simulate and understand their system before you actually go take it to hardware. Just like in the data analysis workflow, you want to focus on developing your algorithm and understanding it, testing it out before deploying that, before generating code from that and deploying it to your hardware. Why? Because hardware is expensive, because hardware is harder to replace, and it could end up taking your time. So the idea of model-based design is to help save anyone time and cost, right? So in this situation, I'm using a drone as a way to represent and help you understand how this workflow operates. So at the highest level, I'm focused on a drone, and I'm focused on the requirements. What does this drone need to do? Does it need to carry 5 pounds for 5 miles, right? At the highest level, we're defining what this thing is supposed to do. Just like the motorcycle, right? If the motorcycle is in this example, and my requirements are, how do I make this motorcycle balance, right? And so at the highest level, we can't do anything until we start breaking down the problem, such as, well, what is the motorcycle made up of, right? What are the different parts? Well, let's take an example with this drone, right? What is a drone? What are the drone systems? What are the systems that make up a drone? Well, here we have engines, right? We have a power management system because we know it needs power. And we have a way for it to control and turn and fly. So right then and there, we've broken down a much more difficult problem into smaller bits. But we can break it down even further. So we can take it to propulsion systems, or engines have propellers. We know that power management systems will require a battery. And we know that there's going to be some kind of software to help the drone fly. So at the component level, I've broken it down to a point to where I can actually take actionable steps. I can buy a propeller, or I can design one. I can buy a battery, and I can definitely design software to be implemented onto a piece of hardware, right? Just like we do with the Arduino. But again, model-based design is all in a simulated environment. So you're reducing the risk, you're reducing the cost, you're reducing the time spent to go and fix hardware that you could end up breaking by not testing out your system properly first, which is where the system integration process comes in. We want to make sure that we are helping to get the system properly working under all conditions before actually putting it all together. And that's when we get to the quadcopter integration, or the drone integration, where we have the final product. And then we go out and test and make sure, can it actually fly 5 miles with carrying 5 pounds? And that's the idea there. This same workflow has been used in not only Boeing, but also Airbus, right? Where Airbus had to design a fuel management system, a controller for the fuel management system, to make sure that the fuel was not only balanced, but was getting to all parts of the airplane at the right time during a flight. And so they use MATLAB and Simulink and other products to help figure that out. And what they did was they ended up saving months of development time. They had a model that they could reuse and test, which means they didn't have to go out to the airplane to make those changes or test on the airplane because that's more expensive. And they reduced the amount of complexity in the system without having to increase more of their staff. So again, we're saving time and cost through these workflows. So MathWorks is focusing on workflows to help with your solutions. And again, this comes down to at the end of each of these workflows comes where we're developing and transporting code onto physical hardware. So let's take a quick look into a Simulink demo. And again, this is going to focus on our actual motorcycle. So here in the motorcycle, here is a model-based design version of the motorcycle, right? Our self-balancing motorcycle. And in here, we have the ability to look at our system, the sensors that it's reading out, the controller that we developed right from our data analysis workflow, and what's causing it to rock back and forth. And we can change the amount of balancing with this interactive dial. So within Simulink, I have the ability to make dynamic systems operate, right? Which is where you see here in the top is our stop time. This allows me to make our system dynamic for a certain amount of time. I can say, I want to run the simulation for 20 seconds. And I can just click on this run button, and this is what's going to initiate and create this system to run for me. So if I run this model, let's go back to MATLAB and I'll show you the simulation. There we go. You'll actually get to see this motorcycle simulation rock back and forth. So let's give it a moment. There we go. So as you see here, this is a product of model-based design. I am focusing on making sure that my system is stable before I actually go deploy it to the code, before I go deploy it to the physical Arduino hardware, because I could end up destroying that hardware, which again does not save me time and cost. So by being able to implement my algorithm within this environment, I can do it safely, I can do it as many times as I want, I can take all the risks that I want, and I can actually continue to learn by implementing this this philosophy of model-based design. And if we take a deeper look, we can go into this what's called a subsystem and actually take a look at how the motorcycle is developed. So what we've done is we've taken 3D CAD models to represent the pieces of our motorcycle to get that simulation and applied forces to it. And what we're using here is SimScape. So in SimScape, we have a product called Sim Mechanics, or effectively the product is in order to support solid models from 3D CAD models and bringing them into MATLAB so that we can actually apply our physics to these parts. And so here we're interacting with SimScape here. At the higher level, we're using some level of MATLAB because MATLAB and Simulink can talk to each other. How do they talk to each other? Well, through this workspace, right? A lot of this information, as you can see, bike body, front wheel, rear wheel, this is all information that has been stored data into MATLAB and is being accessed through Simulink. So we're getting the best of both worlds where these products can talk to each other. And so once I've gotten some understanding of this system and I've set up my controller in a way that that works well for me, I can go and take it now to the hardware version of the self-balancing motorcycle. So this is where you would actually connect your physical Arduino to your computer, and you would initiate your controller and run that, and it would ultimately cause your Arduino to act in the way that you've set it up. So if we go into this specific model, you'll see a little bit of difference, right? So instead of having SimScape blocks that make up my model representation of my bike or my motorcycle, I now have physical Arduino components that I'm talking to and actually sending data to, such as the servo motors and things like that. And so now I'm actually talking to and working with my hardware and seeing, did my control algorithm actually meet its expectations? And so again, this is the power of model-based design, right? This is another workflow to help us support and understand what the problem we're trying to solve is and why we're trying to solve it. And this is going to be beneficial to anyone that is in research or academia, or even students that are going into the industry. Because at the end of the day, companies want to be able to understand how to save time and cost. So if we go back to the presentation now. So I want to wrap things up with taking a few key takeaways here. So again, a few things I want you guys to remember is that MATLAB and Simulink are focused on supporting workflows, right? End-to-end solutions, which is what I just showed between your data analysis workflow and your model-based design workflow. And of course, there'll be others depending on the type of product used within MATLAB, but those are the primary ones. Also, with MATLAB, such as live scripts and the apps, right? You can automate MATLAB coding and for data analysis and actually visualize them and create your auto-generated code from there as you like, along with reports to be able to be shared. With Simulink and Simscape, right, that follow the model-based design protocol, you can design and simulate, either basic systems or multi-domain systems, right? So think about the drone again, right? There are different systems that affect different areas, which means there are different specialties in those areas. So you have to bring all of that together to make sure that it works well. And that's what we mean by multi-domain. It could be mechanical, electrical, software, thermal, and those all have to come together. And you can design and simulate those using Simulink and Simscape. Also, with MATLAB and Simulink, you can control your input and output for Arduino from MATLAB, and you can also deploy those models, like the one I just showed you for hardware, for the motorcycle, onto Arduino boards. So that exact model there is what I would deploy onto the Arduino board in order to get it to follow the control algorithm that I've created. And finally, just one last thing is that based on what you've seen today and what you've seen the industries in which we touch, it's always good to keep in mind that MATLAB and Simulink, in combination with the usage of hardware such as Arduino, are used within academia and industry in order to solve these problems of today and tomorrow. So with that, I want to give you a few resources to help you get started, just to wrap things up. So training for educators and students. This is free training that's available with signing up for a MathWorks account, which is free. But these touch on different areas to get students started. So there's one for MATLAB, there's one for Simulink. There's also some for AI and signal and image processing. So these are all 2-hour modular courses that can be used for professors to get familiar with the product or get their students familiar with it. These can be assigned as homeworks, maybe homework zeros, depending on the prerequisites of the course. With these courses also comes a certificate, so you can actually, so students can turn them in and actually show that they've completed them if you decide to assign them. And this is just for getting started, just for getting your feet wet with MATLAB and Simulink. Now, with the Arduino Engineering Kit, we have a partnership with Arduino to where we provide a 1-year MATLAB license, a MATLAB and Simulink license, plus 10 other focused products for educational purposes, right? So in this kit, you have 3 different types of robots that you can actually build. The one we focused on today was the self-balancing motorcycle. The rover and the drawing robot use MATLAB a little more, so you get a best of all worlds kind of feel when you build all of them and try them all out. Now, in addition to that, we also have the Arduino support page for both MATLAB and Simulink, and it gives you videos on things that you can do and try out, things that other people have done, along with different capabilities and features to give you a perspective of what all is possible beyond just the scope of what these specific robots from the engineering kit were made for. And finally, as a follow-up, again, my role is to help support professors and researchers in their work. And so I, along with a team of others, are here to support any of those efforts if you're willing to get started or interested in getting started, or taking your MATLAB and Simulink skills to the next level, or incorporating them with Arduino in your courses to give students that hands-on hardware feel. So my email is here to follow up with and learn from, and we can go from there and figure out who we can plug you in with to get things rolling. So with that, Rox, I'm going to conclude my presentation, and I think I can stop sharing and send it back over to you.
Yes.
All right.
Nice. So thank you so much, Chad. It was very interesting. So I think now we all get an idea of how to use MATLAB, Simulink networks with Arduino. So that was very, very nice. So remember, if you have, did you want to learn more about the engineering kit, you can go to PITSCO website. And also you can contact Eric Simmons or Brandon Bill for more information. So it's time for the Q&A. If you have any questions, please let us know. I think I already saw some questions there.
Yep. So Rox, I can throw these out to the group. The first question we received is in regards to individuals being in remote learning environments still. And so the first question is, since we are in a remote learning environment, does the program work on a Chromebook?
Yeah, I think there is like the option, or exists MATLAB online, but what we need to make sure is all the add-ons and the project files that need to install also to run the engineering kit are available on Chromebook. So I don't know if we can contact you, or you can send me an email so I can ask our support team if it's possible to run all the engineering kit lessons with using Chromebooks.
I can, Rox, I can pull out the information and I can make sure that you can follow up with this individual directly.
Please do that. Thank you.
Sure. The second question is, can we get a video of this presentation? Absolutely. For everyone who is in attendance and anyone who registered but was unable to attend at the time today, we will be sending out a recording of this webinar. It will likely go out tomorrow morning, so be on the lookout for that. Finally, are there any workshops to take an instructor from start to one project completion?
So I'll take that question. Not necessarily projects, but again, some of the resources that I've shared will help you get started with using them. MathWorks has been supporting a lot of virtual labs, so definitely things when we talk about distance learning with kits and things like that. All the models and resources come with the Arduino Engineering Kit. So you can take, once you have a basic understanding of using MATLAB, you can take it to the next level and utilize the kits in that fashion. And if you have if there's any in between in which you're unsure about, that you can come and reach out to me or anyone else that's on the customer success team at MathWorks, and we can help smooth those gaps and make sure that we can create a flow for a specific project based on your liking.
Nice. But also about also Amy and Roger were asking about the remote learning environment. So also what you can do, or I don't know if you missed the first webinar, but we talk a little bit about the enrollment part. So you can always, or how the engineering kit works is that you invite your students to join to the platform. So that way, and then all there it's come all the installation instructions, so they can everything ready in their computers. But yeah, I think I don't know how it would work for Chromebooks, but this kit you can use it online. So all the instructions, all the exercises, all it's there online. So, but yeah, again, Pam will give me your contact details so I can ask the support team if you can use it with Chromebooks. But it's possible to use the kit as it is, but I don't know about the Chromebook part.
Okay, I think that is all the questions that we received.
Okay, so
go ahead, Rox.
Sorry. No, also Ernesto, which is the engineering kit product owner, is here. I don't know if he wants to add something, a final note. If Ernesto is listening to us. Ernesto, are you there?
Hello, I'm here.
Hi.
Thank you, Rox. I just want to say thank you, everyone, for making this presentation happen. Thank you, Chad, for joining us today, special guest. And it was a great presentation. MATLAB and Simulink, as you know, are extremely powerful softwares, widely used in academy and professional applications. And the whole idea with Engineering Kit is to get you started in a fun way and dynamic way, and exposing some of its most interesting features through the content. I just want to add a quick note on the distance learning part. We're going to follow up with this person really about Chrome notebooks compatibility. However, the whole kit is perfectly compatible with distance learning. I mean, if you have just a laptop or a normal computer that can support MATLAB and Simulink, then you pretty much have everything you need to get started on a let's say hardware-wise, because everything is included in the kit, and the license included should allow you to get access to all the software packages. Or if you have the campus-wide license that is provided by your university, then you should also have access to these tools. There might be support on MATLAB Online, like Rox was mentioning before, but this is something that we're still working on. So you in the future, you might not even need to have MATLAB and Simulink install your computer, just internet connection. But like I mentioned, we're still working on this, and we don't have support for this yet. But yeah, follow up on us. We might be releasing some news soon.
Mm-hmm. Thank you, Ernesto. So again, if you want to know more about prices and learn more information, you can go to PITSCO website, and also contact Eric or Brandon.
Yep, and we did receive, while Ernesto was talking, we did receive one question in regards to what the kit costs. So each individual kit cost $222. And that includes, as Chad mentioned, the 1-year license to MATLAB, and then all of the parts and components to build the various projects, as well as all of the online content.
Yeah, exactly. So it's hardware, software, and the online platform. So every support, all that is included in the price and with the kit. So don't miss our next webinar number 3. There we're going to talk about the Engineering Kit learning platform. So all about the content, what you will find there, the instructions, graphics, all of that. And our special guest will be Leonard George from the Arduino education team. So in 2 weeks, I hope to see you all there, same time on March 16. So thank you again to Chad, great presentation. Thanks, Ernesto, and also, of course, the PITSCO team, Pam, Eric, and Brandon, and all of you. Thank you for have the time to join us. I hope you find this useful, and hope to see you on the next webinar.